Hello and welcome everyone to the Esri Federal Technical Webinar Series. This technical webinar series was designed specifically for federal government professionals who rely on Esri's ArcGIS technology. The series has a total of 5 webinars that you won't want to miss. Each webinar can be found at the URL that you will see momentarily in the chat. If you enjoyed this webinar and or would like to catch the rest of the series, be sure to register today. This webinar today and all webinars within the series will be recorded. Throughout the webinar, should you have any questions, please feel free to submit them into the chat. You may send in your questions at any time during the presentation, and we will collect these and address them during the Q&A session at the end of today's presentation. Now, I would like to introduce you to our webinar, ArcGIS Geospatial Platform, a technical overview, presented to you by Ewan Cameron, CTO Developer Technology, and David Cardella, Product Management Director, Developer and Analytics. Over to you, David.
Okay, great. Thank you. Thank you, Amy. Okay, let's get started. Welcome, everyone. ArcGIS powers your entire enterprise systems. It spatially enables your entire organization, from executives to folks out in the field to knowledge workers throughout the organization. And it's not just people within your organization, but it's also about integrating within other IT systems that you might be using, like ERPs and CRMs. It also includes sensors that are coming in perhaps monitoring real-time information like environmental data, weather data, for example. A successful implementation of a GIS system requires a focused system, a business-focused system. And these are systems that you all build and maintain, and they are specific to the agency in which you work in, and they're tailored to your specific workflows. For example, a land management agency might build a parcel management system, for example. ArcGIS itself is a well-architected IT system, and it has a well-architected infrastructure that you see here, and it's illustrated by tiers. The data tier has various information models and data stores and even live feeds coming in. For example, this could be your relational databases, live feeds coming in from Velocity, for example. The middle tier is the services tier, and it represents data and capabilities. And at this tier, the portal is fundamental. It's how you organize everything. It's how you capture your users. It's how you delegate permissions, for example. And then sitting on top of all of this are apps and APIs, apps that come with ArcGIS, but probably more importantly for all of you, APIs and SDKs that you can use to build your focus systems for your users. And all of this follows well-architected system pillars. You're looking at some of them here. For example, observability, being able to see the health of your system, being able to scale and perform your system, and of course, secure your system as well. ArcGIS itself works with your data. It supports your authoritative content, structured data like imagery, voxels, meshes rather, and more modern data, perhaps like graph data and full motion video. And because it's your data, it provides even more insight into the work and the analysis and the workflows that you and your users perform every day. ArcGIS also includes quite a bit of content, and it's available through the Living Atlas. And the Living Atlas itself contains and includes thousands of curated layers, millions of user-shared layers like different types of base maps, feature layers. There's live data feeds in there. And it's called the Living Atlas because it's just that. Its content is living. It's growing, it's changing, and it's being updated on a regular basis. Some of the items that you can get at in the Living Atlas includes layers, maps, apps, and in a little while, we'll also mention some of the tools and things that you can access within the Living Atlas. Our technology itself is built on a modern GIS architecture that we call Web GIS. And it enables mapping, sharing, analysis, data management, collaboration through a set of services. And it's these services that you can leverage and bring into your solutions and focus workflows. And as a Web GIS, it integrates with all your data sources. It supports a distributed architecture, which makes your data, maps, experiences available anywhere. Ultimately, it's delivering value across your agencies. The main pillar of WebGIS really is the web map. It contains powerful capabilities like the ones that you're seeing here in this slide. Now, for some time, we've looked at the web map and we've talked about the web map as a great way to visualize all your content, as well as mixing it with our content. But the web map is more than that. The web map also defines experiences. For example, what happens when my user interacts with the map, taps on a feature? What's the experience during a data editing workflow? Does the form change based on the data that I've entered in previously? So more and more, the web map defines the experience that your users will have. And WebGIS includes both web maps and web scenes, and it's a great way to engage and interconnect with everybody. It provides a common language for your agencies, where it's used to communicate within people within your agency, but also folks perhaps outside of your agency. It could be the public as well. So web maps provide this seamless experience between everybody. A web map can be authored, it can be shared, it can be opened in a browser or on a mobile device. It can be used offline, and if there are any changes, those changes can get synced back to the original service. So maps and scenes provide a common framework for collaboration. Now, as developers, web maps and web scenes are a powerful GIS tool that you can leverage. So first off, you'll write less code. Rather than building a map in code by accessing all the layers, stipulating what the rendering of those layers is, also developing or implementing what the action should be if someone taps on a feature, for example. All of this comes to you, for example, in a web map with literally just a couple of lines of code. If you need to make changes to your application, a lot of quick app updates can be recognized simply by changing the map rather than cracking open source code and redeploying. So the bottom line is that you'll really reduce your development costs and you'll get your solutions in the hands of your users much quicker. So probably the best way to see the power of WebGIS is through a demonstration. So I'll hand it over to Karsten and Anne for that. And Karsten's going to start by talking about data pipelines, which is a way to bring disparate data together. And then Anne will show us the power of WebGIS. So let's take a look.
Data pipelines is a powerful data integration tool in ArcGIS Online. It enables users to read from multiple sources, perform transformations, and publish results as hosted layers, all within the WebGIS. To demonstrate, let's say Anne and I are analysts, and we've been asked to identify sites for building new data centers. We decided to split the work between us. I will do the data preparation, and so that it's ready for Anne to analyze. And of course, I plan to use data pipelines. Let's review the factors that make up my data pipeline setup. Most importantly, I need land that's available for data center construction, and I decide to use several land use shapefiles from the digital landscape model. This data has been staged in an Azure Blob Storage container. Access to the power grid is vital, and data centers should be located near high voltage power lines or substations. This is a map of the German high voltage grid, and it's backed by hosted layers in ArcGIS Online. Data centers need high-speed fiber optic networks. and I plan to use broadband availability data. This tabular data is available at the county level, and it includes broadband availability metrics such as fiber optic length, network length, and the number of points of presence, which are locations where networks interconnect and that can act as access points. Additionally, I need locations that have low natural disaster risk. My primary concern is flooding, so I'm using flood zone data from the federal government hosted on ArcGIS Enterprise. Let's look at an initial data pipeline. My data pipeline has two inputs. One is the land unit shapefiles, which represent potential sites. This points to a cloud storage data store item in my Web GIS, which is linked to an Azure Blob Storage container and a shapefile in that container. My second input are the transmission lines, which are used to calculate the distances. And that's a hosted feature layer in ArcGIS Online. The first step is to join the land units to the transmission lines using a one-to-many inner join. And I use a near-planar spatial relationship with a cutoff distance of 10 kilometers. My target geometry are the land unit geometries, and my join geometry are the transmission line shape. This generates an intermediate data set that has both geometry fields, and I take advantage of that to calculate a new field called transmission line distance. And I use a arcade expression using the arcade distance function to calculate the distance between both of those geometries in meters. Because I'm interested in the closest geometry, I use the Summarize Attributes tool by matching on the land unit feature ID and aggregating on the new transmission line distance field. Because the Summarize Attribute tool only returns the match and summary fields, I need to rejoin my results to the land unit data set, this time using an attribute relationship, before publishing the outputs as a hosted layer. Now I need to repeat these steps for the other factor layers by taking the outputs of this join and joining the other factor layers. Soon I will have a data pipeline that looks like this, and I can run it, which will take about 15 minutes to complete. This is what my output looks like. It is a hosted layer that has all the fields from the original land unit data set, but also includes my enrichment fields, such as transmission line and substation distance, broadband availability metrics, information about flood risk. I even included a highway proximity and protected areas. Now I'll pass it to Anne, who will show us how to style, analyze, and share this data.
Awesome. Thanks, Karsten. So next, I'm going to use the power of Web GIS to visualize, analyze, and share the data that Karsten just created so we can provide decision makers with the best location to place new data center in the Frankfurt area. I'm going to visualize, in the map viewer, visualize factors like the distance to highways and power lines, fiber availability, and flood risk, balancing connectivity, power, and safety. So I've already brought the data that Karsten just created into my web map, and we'll start by just updating the style. We can choose from one of the existing attributes in the layer, like distance to highways, and Smart Mapping will automatically choose the best renderer based on my data. Should just take a second. There we go. Let's look at another field. Take a look at flood risk. And the renderer will update fairly quickly. While each attribute tells part of the story, but we should bring them together so that we can take a look at all of the factors together instead of visualizing them one by one. So I'll use Arcade to do this. We'll use Arcade to create a single suitability score that brings all of these factors together so that we can provide decision makers with the best location for a new data center. Now, to help me write my Arcade expression, I'm going to take advantage of that Arcade assistant that I just showed you earlier. We'll start by just passing in a prompt of natural language, providing a bit of context as to what the values in my data are. So it says create an arcade expression that calculates a weighted data center site suitability score from 0 to 100 for each parcel, checking for null values, and based on the distance to the nearest high voltage transmission line, the distance to the nearest substation, the total length of nearby fiber optic cable, the count of network POPs, the distance to the nearest major highway, and flood risk. Flood risk is a value between 0 and 1, where lower is better, and the POPs average around 100, where higher is better. Now, notice that I do not need to provide the exact field names. The assistant is able to figure them out for me. Let's also provide this expression with a name. We'll call it the data center suitability score. Okay, looks like our assistant has generated a response, and I can easily add it to the editor and test it against my data. All right, let's take a look at what this expression is doing. First, it's checking for null values, just like I asked. And then we'll normalize each factor on a 0 to 100 scale, and then assign weights to each factor. So maybe I want to change some things here, like I'll adjust the flood risk weight to be 0.2 and the highway weight to be 0.1. Then it'll calculate the weighted sum and return our suitability score. Great. Let's see what this looks like in our map. Okay, so in less than a minute, we were able to turn raw attributes into an analysis-ready field using Arcade and AI to help me find the best location for my new data center. I'll go ahead and update the color ramp here and adjust the color stops. And immediately we can begin to see which parcels begin to stand out. I can compare this to the factors that were used to create my suitability score to confirm these findings. So if we zoom in, we can see that these areas in dark green up here are highly suitable for our new data center, as they are close to a substation and have highways and power lines nearby. On the other hand, these areas in the flood risk zone are displayed in a light gray color, showing that they are not as suitable for our new data center. All right, next, let's go ahead and add a pop-up to create an interactive experience for users to learn more about the parcel under consideration for the data center. We can use this to find more information about the factors that are contributing to our suitability index, to provide that additional context that we need. So for the sake of time, I've already configured this pop-up, but let's take a closer look at how it was put together. So here I have a text content type that is showing the overall suitability, that suitability score, referencing a very similar expression to arcade expression to the one that I used to style my data. And I'm also color coding that expression, or that suitability score, again using an arcade expression. Now these are all done through arcade expressions, as is this bar chart, which really shows how you could use Arcade to customize your pop-ups and make them data-driven. Now this pop-up will update based on where I click in the map and can really help provide that additional context that's needed when determining where to place that new data center. Now, to focus our analysis, let's go ahead and narrow it down to parcels that are specifically designated for industry and are large enough to hold a data center. So I'll apply a filter in effect. So I'm filtering where the object type is designated for industry and where the shape area of my parcel is greater than 20,000 square meters. Great. This looks like it really narrows down to just a few sites that are great for our new data center. And I can zoom in to a candidate location and add bookmarks for each of these. Okay, now it's time to share our web map as an interactive instant app, so we can provide decision makers with the ability to explore this data on their own. I'll go ahead and click Create App, choose Instant Apps, which will launch this Instant App Editor here. I'm going to select the sidebar application, which is perfect for viewing interactive content like bookmarks and pop-ups and a legend in the sidebar. Now notice that everything that I configured in my web map, all of the styling, the filters and effects, the bookmarks, the pop-ups, are all carried through automatically. So this really shows that power of the web map here, bringing all those interactive experiences directly into your applications. And when I'm ready, I can publish the application and launch it in a new tab, zoom to one of the candidate locations, and easily copy the link to share it with stakeholders. So in less than 10 minutes, we went from raw data to an explainable, shareable decision-making map using Web GIS to make smarter, faster site decisions. And this is the power of Web GIS, turning complex data into clear, explainable insight that anyone can explore and share. Thanks. Back to you, Dave.
Okay, great. Thank you, Carson and Ann. That was a wonderful demonstration. So far, we've discussed kind of the capabilities at a high level across the ArcGIS platform. However, as developers and GIS specialists, you work with capabilities through products, and you're looking at the foundational products here. So I just wanted to touch upon each one of them because they have their own unique experience that you can leverage as developers. The first up is ArcGIS Pro. You can customize ArcGIS Pro without using any code. So really, Pro is a platform that you as developers can use to customize in different ways. Without code, you can change the user experience, the UI, simply by interacting with a configurable UI itself. You can automate Pro through ArcPy and through the Python API, but you can also customize the behavior of Pro either through arcade scripts or through the Pro SDK for .NET. With the SDK, you can build add-ins that bring completely new functionality to your to ArcGIS Pro, or you can implement a managed configuration that gives ArcGIS Pro its own look and feel, such that your end users may not even realize that they're using ArcGIS Pro. Enterprise not only allows you to publish your data within your own infrastructure, but it can also be extended in different ways through interceptors, through custom data feeds, through web tools and web hooks, automated through Python and notebooks and other scripting languages. You can also use our client SDKs to build apps that sit on top of ArcGIS Enterprise. ArcGIS Online provides a similar extensibility points that we just discussed with ArcGIS Enterprise, which includes web tools, web hooks, and also integrates very tightly with any apps or focus solutions that are built with our maps SDKs. In addition, you can also take our no-code, low-code tools like dashboards, instant apps, and story maps and build applications without writing any code. Those no-code, low-code tools can also be used with ArcGIS Enterprise. ArcGIS Platform is a developer's product or a developer's solution that gives you all access to ready-to-use location services in the form that you're expecting. You want to use some geocoding and some geo-enrichment, and with some base maps, you can go ahead and do that, or perhaps some routing, you can go ahead and do that. And so our maps SDKs are supported fully within Location Platform, but we also fully support many popular open source mapping SDKs like you're seeing here: Leaflet, OpenLayers, MapLibre, as well as Cesium. ArcGIS itself is open and interoperable. We support many open initiatives and in many ways. For example, we support open standards such as OGC, W3C, and ISO in order to make it easy for you to interoperate with ArcGIS. We've implemented an open architecture so that you can use our services regardless of the framework or the language that you prefer. ArcGIS is being enhanced with new capabilities, as well as some existing capabilities using AI. And what you're looking at here is how our work around AI and integration within ArcGIS breaks down. So let's briefly touch upon these. The first is GeoAI, and this is all about advancing science. So in the area of GeoAI, we provide a library of pre-trained models. These models are available through the Living Atlas, and they are making geospatial AI more easier than ever. There are well over 100 of these models, and they include land cover classification, extracting building footprints, identifying other features such as transmission towers, and this can be done both in 2D as well as 3D. And these models work against really large, massive data sets, scaling and making sure that you can scale and automate your workflows when using them. In the area of AI assistance, it's all about providing you with a streamlined way to make your daily work easier, faster, and more efficient. And so we have a number of different assistants that have been integrated into various aspects of ArcGIS. We saw Anne show the arcade assistants in the map viewer just now, but there are also other assistants, like a notebook assistant that can help you troubleshoot code, generate code, or a pro assistant that can help you with productivity. And as developers, specifically with the pro assistant, you have access to its Pro Assistant framework that you can use to further customize. The last area is all around agents and agentic AI, which really focuses on collaboration. And we break this up into two areas. One is applications that are third-party applications, but they need to be geo-enabled, or they need geography to complement them. And in this area, we're adopting a well-known standard called MCP, Model Context Protocol, such that we will expose our location services using MCP so that you can use any third-party application or third-party client to tap into those location services, both from a data perspective as well as from a capabilities perspective. The other part of agentic AI is geocentric applications or GIS applications. And what we're doing there is we're bringing agents that you can use and leverage into your GIS workflows. We're also allowing you to develop your own agents that you can then bring in to your focused experiences as well. So ArcGIS is a geospatial AI platform, and it has an architecture that's very similar to the multi-tiered architecture we saw earlier, and it fits in quite nicely. At the data tier, this includes pre-trained GeoAI models, large language models, content from the Living Atlas. In the AI services tier, there are various AI skills or custom actions. And we, as well as AI agents. And finally, at the upper tier, includes apps that are included with Esri, apps that you build, as well as apps that are agentic in nature, whether it's your custom apps or apps that users can use directly from ArcGIS. And so ArcGIS itself has many hooks or entry points into it that you as developers can use to get your work done. We break these down into three high-level areas. First is automating through Python and ArcPy. Next is extending, that's extending Pro and Enterprise through their various extending SDKs. And the third is creating applications or solutions or experiences through for your users through various Maps SDKs. SDKs that can be used to build applications that run in the browser, on devices, etc. And so that's a good segue into our next kind of section of the webinar, which is all about building apps. And to take us through that, Ewan, I'll hand it over to you.
Thanks, David. I'll just share my screen here. Let me try that again. Hopefully you're seeing my screen now.
Yes. Yeah.
Okay, great. Yeah, thanks, David. That was a good sort of high-level overview. But the reality is, as David said, ArcGIS powers your enterprise systems, but actually, how does everybody in your organization actually interact with enterprise systems? They interact with them typically through applications. Some of these applications are user focused. Some of these applications are back-end apps that are running on servers that are just doing the data connection. But ultimately, you need these apps to really make ArcGIS Enterprise work throughout your system. But it's not just the technology, it's about the people that make that work. And the people that make that work, it's the people like you on this call. Sometimes you're GIS professionals who are really close to the technology, and you're maybe using some of the low-code, no-code builders to build out custom experiences. Or you could be developers building back-end plugins to enterprise, or some focused applications using a variety of sources. Architects building and designing the system, DevOps engineers that keep the system up and running and available 24/7 for all the users within your organization, etc. And the way that I like to think about you all is I really see you as builders, because the reality is, to unlock the full potential of technology, organizations like the ones that you work for, you need to do more than just get technology and tools. You actually need the people that make these technologies and tools work for the organizations. Builders are developers, they're technical practitioners who you see a real problem that needs to be solved. You don't wait for a perfect solution to be delivered to you. You take your skills and the technology that's available and you mold it into a solution, and then you ship it. And they really connect, if you like, the business problem that your organization has to the data that your organization has, to the sort of the APIs and the SDKs, and you bring it all together and deliver a package of functionality. And it's really you as builders within your organizations that make ArcGIS work. And that's why your role is so important within your organizations. In high performing organizations, builders, they're not limited to a single team or title. They really show up wherever people are willing to learn new tools, automate the boring parts, improve the systems. It's kind of incrementally. What defines a builder? It's not the language that they choose or even the technology. It's their mindset. It's the ownership that you bring to the problem, the curiosity that you can solve problems with technology. And it's ultimately a bias to shipping working software. You always want to ship something that works for your users. It might start really small, and over time you iterate on it and you evolve it, but it's using your skills and the ability to be agile with technology that really makes you so special and so valuable for the organizations that you work for. So builders are really critical to the success of ArcGIS within any enterprise organization, big or small. And that's really because you're meeting your users where they work. You're building out these custom focused experiences and delivering ArcGIS in a form that really works for these customers. Now, perhaps the easiest way to do that is to start using our low-code, no-code technology. And many of you will be building dashboard applications, which are all about building an application that reports a lot of data, but in a way that's visually impactful, easy to understand, and can just at a glance, your users can find out a particular status of a system. And the team over the last few releases has been really thinking about how dashboards are being used within enterprises. So it's not just about building sort of new widgets that can go into your dashboard that expose a piece of functionality. It's about supporting you building dashboards and making them easy to maintain and deploy on multiple systems. So recently the team's been working on functionality to make it easy for you to repair dashboards if a web map changes or the data source changes. Now it's a very simple case of pointing to a new web map, lining up the data sources, and you can be up and running in a matter of minutes instead of reauthoring the complete dashboard. Or maybe you're deploying dashboards into a development environment, QA, and finally up to production. Moving them through the tiers has been quite hard work, but the team again has been working with extensions to the Python API to make it easier for you to move your dashboards through your tiers, and it's just all about making your dashboards more easier to use within your enterprise, easier to use, easier to maintain. And finally, the team's been thinking about what it takes to make your dashboards even more visually impactful with a set of tools to really allow to kind of tell you where you might be able to improve the visual appearance, the visual contrast, etc., maybe on some of your text. And so the team's been working a lot there. Next up is Instant Apps. And Instant Apps is all about taking your web maps and your web scenes that you've created as part of that Web GIS workflow, and then making them available in an easy-to-use form for your end users. You saw Anne do that in a demonstration just a few minutes ago, where she took all the work that Carsten and Anne had put together into that web map. But before she shared it, she didn't just share the link to the web map for it to come up in the map viewer. She actually shared it inside of an Instant App by configuring a template, and it just provides a better user experience to the end users. And there's a number of new templates that are available within Instant Apps. So if you haven't checked them out for a while, strongly recommend just going to your map viewer, share as option, pick an Instant App, and have a look at the templates that you can choose from. And you can really use combination of these templates to build out complete solutions, something that the team continues to work on there. And then finally, the last low-code, no-code builder that I'll talk about this morning is Experience Builder. That's, again, powered by Web GIS because it takes the web map as so much of its content. But Experience Builder is more than just building a single page web application. It's about building out a complete web experience, potentially over many, many pages. And some of these pages can have maps on them. Some of these pages maybe have no direct mapping content, but there's still a lot of content that you could build as part of your web experience. And one of the latest features that team's been working on is the ability to sign in to the finished application. And depending on your role within the organization who's signed in, whether it's a anonymous access or whether it's a particular user in a particular group with a particular role, they can get access to different pages within the experience. So you can really build out very sophisticated web experiences with Experience Builder. And there's also a developer edition where if we don't have a widget that's available for you to just drop into your application, but you do have JavaScript skills or you know somebody who does, you can always extend Experience Builder with your own custom widgets to really focus on your organization's mission and make it easy for many people to build custom experiences, but dedicated to some aspects of your organization's specific work. So that's the low-code, no-code builders. Next up is the client APIs and SDKs. And when it comes to client APIs and SDKs, you've got choices as a developer. There's the many Maps SDKs that we support. There's 8 of them for web application development, game engine development, or native development. We support open source APIs and the common open source mapping libraries. And when you're building out your applications with these client mapping libraries, you're always sitting on top of location services. These location services can be coming from our SaaS or PaaS, as David described, or they could be coming from your own enterprise or another organization's enterprise instance. But when you're working with location services, that's really the modern pattern for building applications. You pull in location services from Esri, you might pull in services from your own organization, you might pull in services from other third-party orgs, but you pull them all together and you bring them together in the application. So we've been doing quite a bit of work with location services. We've been enhancing existing ones like geocoding. There's a batch geocoding capability now. There's routing enhancements. Base maps has seen a number of enhancements with new data content as well as new delivery mechanisms such as static base map tiles, where you get a static image of a vector tile. So if you don't want to load a vector tile rendering engine into your client, you can always ask for a static base map tile. And we've also just released a brand new service called the static map service. This is where you can give it an arbitrary extent and ask it to produce an image of 500 pixels by 500 pixels because you want to put it in, say, an email or a very simple web page that you don't want to load dynamic JavaScript libraries into. And you can put some graphics on it and then generate the image on the server and return it to you. That's currently in beta. There's a QR code on the screen right now. If you click that, go to that QR code link, that'll take you to the beta program. You can sign up and start partaking in the static map service. And we've had a lot of interest with this new service just in the last couple of weeks since we put it out there. When it comes to open source mapping libraries, we kind of support the 4 most common open source libraries that are available: Leaflet, MapLibre, OpenLayers, and Cesium. I know a number of you from talking to you over the last few months are using open source. I talked to a group of developers at USGS. They were heavily into Leaflet, and they really like Leaflet. Well, we have a plugin for Leaflet, which makes it easy for you to work with ArcGIS services. Another group at NOAA, they were using OpenLayers. And again, OpenLayers works great with our services, whether it's vector tiles or imagery tiles. And these plugins that we develop for the open source, they're not 100% required. You can use the open source libraries just as is. But if there's a plugin available from Esri, we would strongly recommend you use the plugin because it really streamlines your workflows as you work with our location services. We also have an open source library ourselves called REST.js, ArcGIS REST.js, and that simplifies just working with location services and when you're just wanting to maybe touch a little bit of geocoding or the like. So what I'd like to do now is pass over to a demo from Anita, and she's going to show open source in action.
Thanks, Ewan. Many developers, including myself, like to build lightweight, location-based applications that use an open-source mapping library. This app, for instance, uses MapLibre GLJS and ArcGIS location services. To make accessing location services easier, we have ArcGIS REST.js, an open-source library designed to work well with client-side mapping APIs, including MapLibre. It provides wrapper classes for ArcGIS services, making them easier to integrate within an application. We also have MapLibre ArcGIS, an open-source plugin designed to efficiently display base map styles, feature layers, and vector tile layers. In this app, I use both. I use the MapLibre ArcGIS plugin to display a style, and I use ArcGIS REST.js to find hotels within the map extent and to return their details. In the code, we can see that I'm using the basemap style class provided by the plugin to set the ArcGIS navigation style. With REST.js, I use the find places within extent operation to find the hotels before using getPlaceDetails to return attributes such as the street address. Building lightweight applications is just one way you can use open source technologies. But we also know that some of you are also using open source technologies to build GIS applications that require your authoritative content hosted in ArcGIS be pulled in as, for instance, a feature service. Though typically, if you're using a library such as MapLibre, you have to access features from a feature layer as GeoJSON. In this app, I try to display features from a building footprints feature layer, but due to the scalability of GeoJSON, the performance is slow, and I'm limited by the amount of features I can display on the map. These limitations make it difficult for me to effectively visualize my data. Luckily, the MapLibre ArcGIS plugin solves these problems for me. Its feature layer class optimizes the way in which features are accessed and displayed. So let's take a look. In the Network tab, we can see that these features are being accessed as PBF tiles. This means that features are dynamically loaded, on demand, thereby significantly improving the performance of this application as well as the way in which they're rendered on the map. Now that I'm able to visualize all my data, I can take advantage of some of the inherent capabilities of MapLibre that I'm familiar with, such as extruding them based on their building height, as well as further styling them based on other attributes such as the construction year. To display these features is simple. Using the feature layer class provided by the plugin, I set my portal item ID and then add the layer to the map. We'll continue to enhance the capabilities of ArcGIS REST.js and the MapLibre ArcGIS plugin. We'll also continue to identify the ways in which we can help you as open source developers leverage our services within your preferred mapping APIs. Back to you, Ewan.
Thank you. Anita, nice combination there of using Web GIS with the portal item, accessing the feature service, and then adding them into your open source mapping library. Moving on to the Maps SDKs, and we've got 8 of these. We'll start with game engines. We support the 2 leading game engines of Unity and Unreal. And we really see game engines being used to build these very immersive experiences that are so important in deployments like simulation or digital twins. And so the team continues to build out the capabilities, adding more and more layer support for different data types and specific areas of functionality to allow you to really build out applications using this immersive technology. With native SDKs, we continue to build great support across 5 different SDKs there for Swift, Kotlin, .NET, Qt, and Flutter. You can build mobile applications that run natively on the device. You can build desktop, but you can also build embedded applications for very specific use cases. And we really see these SDKs being used for building applications that aren't necessarily always connected to the network. And that's really where the power of the native SDKs come alive, because they're designed for offline use. It's not a byproduct, and it just happens to work offline. We put a lot of thought and energy into making sure they work great, whether you're connected to the network or whether you're not connected to the network. That could be temporarily disconnected, or it could be permanently disconnected, where all the content and the applications are loaded, side-loaded, if you like, onto the machine. You can do data collection when you're offline. You can do analysis when you're offline. We've got visual analysis as well as data analysis, and we've been working on 2 very important brand new pieces of functionality that will be released in April with our upcoming release of ArcGIS native SDKs. We've got a new local scene view where you can pick any spatial reference for your coordinate system, and you see it in sort of that local context, We've also been working on a really exciting project for doing spatial analysis all on the device using the latest GPU technology, where we get blazing fast performance. Think about doing view sheds in under 10 milliseconds. And so that opens up a whole new class of applications that can be built using the native SDKs. Finally, the last Maps SDK I want to talk about is the JavaScript SDK. We use that for building out web applications and web experiences. It's been built from the ground up with performance in mind, with embracing the Web GIS architecture in mind. It works great in 2D or in 3D. And the team most recently has been working on revolutionizing the user interface components that are used by the SDK to make use of web components. Very standard sort of HTML way of building applications. And so all of the old widgets that you may have been familiar with, they're all being migrated over to web components. And we really want to encourage you to start thinking about web components if you're using the JavaScript SDK and building your applications with these. So to show us a quick demo on web components, I'm going to pass it over to Arjan.
We start here in the map viewer, where I create the experience that I want to give my users with my data. We're looking here at the traffic accidents in the Netherlands from 2003 to 2024. Zoomed in to the region of Amsterdam, and the data is visualized by the outcome of the accident. Notice that my data is time aware, and I configured different charts with my data, like by year, the maximum speed of the location, and also by outcome. So now let's transform this map into an app. And important for me is to take the item ID with me for further implementation. The documentation of the JavaScript SDK shows me all the different maps and components that I can implement easily. And one of them is the map component itself. The only thing that I need to do here is paste that item ID, and styling, pop-up, and other configurations are all being carried over automatically. Now, with the latest release of the JavaScript SDK, we introduce slots to the map and the scene component. They are fundamental for web components. Slots are native attributes and predefined placeholders. And in this example, we see the zoom, the legend, and the layer list in their corner. And because I can put any UI component in the slot, I have also a calcite notice in the bottom left. Now let's add a layout to this map. I'm using Esri's calcite design system, where we offer many configurable components and a large collection of icons. And one of those components is the navigation component. So I already started, and here in this app, we see on the left side the panel, and on the right, with the same line of code, the map with the components. I prefer to have my legend and my layer list on the left and have the content of my notice in the navigation. So here we see the layer list and the legend on the left. Let's have a look at the code, how we did that. Here we see the layer list component, and we set the reference element to the map component, so we keep that connection between the map and the maps component intact. And the same is what we did to the legend as well. Now that the basic app is in place, let's add some styling. The design tokens from the calcite design system showed me in which way I can style my components. It could be a color, could be a border, or it could be a corner radius. So I already started and have some colors defined, have them attached to my design token variables, and this is the result. Now that I styled my app, I can also introduce a dark mode to have my data popped even more. And notice that I have here a map with the darker base map to have the app more visually aligned. We now introduce a more harmonized way to style both the calcite components and the Maps SDK components. So here in the code is how we did that. We changed the class of the body tag from light to dark, have some custom logic to do so, and we changed the item ID from the map into the other map with the darker base map. Now let's add some more functionality to our application. Let's add some charts. And charts help us to emphasize trends and explore the data in different ways. Remember that I showed you the charts in the map viewer? I put them here underneath the map, and the only thing that I needed to do is have the ArcGIS chart component set the layer item ID and an index, because I can have multiple charts with my layer of web map. Now that the charts are out of beta, I can easily load my chart that is saved with the layer, or I can configure it programmatically. Now for the final step, we're going to add some more interactivity. Here I added the time slider, and I changed the configuration of the charts. By changing the time or moving the map, you see that the charts get updated. I also added a spotlight from our core API to highlight here the features on the map and show on the left a statistic panel with the maximum speed of the location in the highlighted area. What you just saw is from creating in the map viewer that experience that we want to give our users with the data, adding a styled layout, adding functionalities with our maps component, and add that custom logic from our core API. And with that, back to you, Ewan.
Okay, thank you, Ariane. Good example there of using the calcite design system along with the JavaScript SDK. So just to wrap things up, I think the evidence is pretty clear from the many organizations that I interact with and have meetings with over the last few months, that users and organizations are evolving. Users are evolving because they're expecting more of you as technologists, and they're expecting more from the technical solutions. Organizations are evolving because you, as the builders within these organizations, are evolving to really start to leverage all the tools available to you to be able to deliver the solutions that your users are wanting, and really allowing your organizations to be really competitive. It's that ability for you to be agile with technology that maximizes the impact that your organizations can have. So that concludes David and my section. I'd like to pass it back to you now, Amy.
Okay, great. Thank you so much, Ewan. We're now going to, we have maybe a minute left to address a question that was submitted. You can still submit your questions. We can address them in a blog post later if we're not able to get to them. But one of the questions that was asked was, to what degree does Esri support the use of ArcGIS apps and APIs with open source apps, tools, data, formats, and technologies?
Okay, well, I think hopefully you saw from Anita's demonstration, and we talked about open source client mapping libraries. We fully support developers using these to build apps, but we support many ways to interact with other forms of data that maybe are not naturally supported by ArcGIS. You can build plugins to both ArcGIS Pro. You can build custom data source plugins to ArcGIS Enterprise, where you can reach in to your custom data feeds and data sources. So that's another way of definitely interacting with them. So we definitely embrace open source as technology. We use it ourselves, and we definitely encourage users to use it if it's appropriate for their solution.
Great. Well, thank you, Ewan. Thank you also, David, and thank you to everyone today for attending the webinar, ArcGIS Geospatial Platform and Technical Overview. If you have any questions about this webinar, or anything else that was mentioned during this webinar, we encourage you to post them in the Esri community user forums for developers, as there may be others who also share your same question. And once you leave the webinar, you'll receive a survey on the presentation. We would appreciate it if you complete that and provide your feedback. On behalf of Esri and our presenters, thank you for joining us today, and have a great rest of your day. Thank you.